Welcome once again into my YouTube channel whose name is Knowledge Entertainment. And now we continue the second part of trigonometry. In the previous one we have learned how to convert angles from sexagesimal system into centesimal and from centesimal system into the sexagesimal system. Now we'll see how to convert angles from sexagesimal and centesimal systems into the circular system and vice versa, and then we will move ahead to the trigonometrical functions, sine, cos, tan and its identities. So as we know that 360 degree is angle of complete rotation, complete revolution, and is equal to 400 grades in centesimal system and is equal to 2 pi radians in circular system. Further, 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. 1 grade is equal to 100 centesimal minutes and 1 centesimal minute is equal to 100 centesimal seconds. This is known to us as we have learnt all these things in the previous lecture, and now we will move on to the questions of conversion from sexagesimal and centesimal systems into the circular system and vice versa. So I am taking some questions once again. So for example, one of the questions is convert 58 degree 28 minutes 14 seconds into circular system. So this conversion is now required, and how we will proceed, the manner is almost same. First we will convert these seconds into the minutes. The minutes will be added then. The total minutes then will be converted into degrees and the degrees will be added then. And then we will use the conversion that 360 degrees is equal to 2 pi radians, and we will convert accordingly this angle into the radians. So I am going to give the solution now. Solution. Here the angle is 58 degrees, 28 minutes and 48 seconds. So first of all, I will convert these seconds into minutes, and we know that in 1 minute there are 60 seconds in sexagesimal system, and 14 seconds therefore will be converted into minutes by dividing it by 60. So what we will get? We will get 58 degree, 28 minutes, 14 divided by 60 minutes. And further this will be 58 degrees, 28 minutes, and when we will divide it, we will get 0.233 minutes. And now these are minutes, these are also minutes, so will be added, and in totality we will get 58 degree, 28.233 minutes. And now we will convert these minutes into the degrees by dividing by 60. So it will become 58 degree, 28.233 divided by 60, and now these are degrees. So it will become 58 degree, and here we will get 0.04705 degrees. Now these are degrees, these are also degrees, so will be added, and you will get 58.47055 degrees. And now the main conversion. We know that 360 degrees equal to pi radians. So these much, that means 58.47055 degrees will be equal to, by using unitary method, it will become, it is 2 pi, sorry. So it will be 2 pi divided by 360 multiplied by 58.47055 radians. These much radians. So now we will convert these radians properly, and the calculation work is now needed. How to calculate now? This 2 will be cancelled. Here it will become 180, and the value of pi, approximately we know that it is 3.14. So I am using the value 3.14 multiplied by 58.47055 divided by 180 radians. This is the quantity now. And now a little bit multiplication work, and solving this quantity you will get the answer whatever the radians will be. It is just a calculation work, so I am leaving it for you. You can multiply these, you can divide it by 180, and you will get the radians, which will be the value of 58 degree, 28 minutes and 14 seconds in sexagesimal system. Now a similar question I am taking from centesimal system into the circular system. So the question is, convert 72 grads 35 minutes, now minutes in reverse order, that is centesimal minutes, 50 seconds into circular system. Once again we have to convert this angle into the circular system, and the procedure is almost same. So 72 gradients, 35 minutes, 50 seconds is equal to, first we will convert these seconds into minutes, and this time we will have to divide by 100, because 1 centesimal minute is equal to 100 centesimal seconds. So it will become 72 gradients, 35 minutes, 50 upon 100 minutes, and 50 divided by 100, we know that it is 0.5. So 0.5 minutes here, and these are 35 minutes, so you will get 72 grades, 35.5 minutes. And now these minutes will be converted into gradients by dividing it by, once again, 100. So it is 72 grades, 35.5 over 100, and these are now grades. The calculation work is easy, because this time we have just to divide by 100, and dividing by 100 and then adding to it, you will get 72.355 gradients. And now the calculation work, that is 400 gradients is equal to 2 pi radians. Therefore, by using unitary methods, 72.355 gradients will be equal to 2 pi divided by 400 and multiplied by 72.355, and these are in radians now. So once again you are left with the calculation work. Substitute the value of pi, this will be cancelled, 200. Further you can just divide it here by 100, and the value of value of pi is 3.14, and divide this quantity by 200, you will get 0.36175 radians. And now you are just to multiply these two, and multiplying these two you will get the answer in radians. So this angle in centesimal system will be converted into the radians, that means circular system. And now the reverse process. Let us take some question of converting angle given in circular system to sexagesimal or centesimal system. So let us take one question. Convert convert 7 pi upon 9 radians into sexagesimal system. Now, the given angle is 7 pi upon 9 radians. As it is 7 pi and we know that one of the values of pi is 22 by 7. So that will be more suitable here, because 22 over 7, you will write 7 will be cancelled out. So you will get 7 upon 9 into 22 upon 7 radians, and what will be there will be then, or we can use some other, if we either we are to cancel it and then to convert, or there is one more thing, that we know that 2 pi is equal to 360 degree. So 7 pi upon 9 will be 360 divided by 2 pi multiplied by 7 pi by 9, and these much degrees. And I think this will be more easy because pi is here cancelled, 9 is also cancelled, you will get 40 here. 2 will be cancelled, you will get further 20 here. 20 into 7 will be 140 degrees will be the answer. If there is some decimal part, suppose 140.3217, then 0.3217 will be converted into the minutes by multiplying it by 60, and then once again the decimal part will be converted into the seconds by multiplying by 60. So we will take some more question of conversion. I am taking one more question of conversion from this circular system into the centesimal system. Suppose the angle is 8 pi upon 11 into centesimal system. Now we have to convert the angle into centesimal system. In centesimal system we know that 2 pi radians is equal to 400 grades. By using unitary methods, 8 pi upon 11 radians will be equal to 400 divided by 2 pi multiplied by 8 pi by 11 gradients. This is cancelled here, 4, so you will get 1600 divided by 11 gradients. So further divided by 11, it will be 1, 4, 5.45, approximately 4445, or you can say 4445 gradients. Now the integral part we will keep 145 gradients, and decimal part 0.4445 we will multiply it by 100 to convert it into the minutes. So what you will get, you will be left with 145 gradients, 44.45 minutes. Once again the integral part will be kept, 145 gradients, 45 minutes, and 0.45 will be multiplied by 100 to convert it into the seconds. So what you will be left with, 145 gradients, 44 minutes, and 45 seconds. This will be the conversion, and this is how we have to deal with 3 systems of measurement of an angle: sexagesimal, centesimal, and circular systems. Now we move ahead. Now the basic trigonometrical functions we will talk about. In the previous classes, maybe in 9th or 10th, you must have learned about sine, cos, tan, etc. Here it is the positive direction of x-axis, it is the positive direction of y-axis. From here we count the angle 0 degree, and as we move towards the y-axis, here we travel 90 degree. Once again, from y-axis to the negative direction of x-axis, more 90 degree means 90 plus 90. So this whole angle will be 180 degree. And then once again, one more 90 degree rotation, and it will be 270 degree, and finally it will become one complete revolution of 360 degree. We know that in a right angle triangle, suppose we are talking about this angle, suppose this is the angle theta. There is one right angle. The side opposite to the right angle is always hypotenuse. The side opposite to the concerned angle, this is the concerned angle theta. The side opposite to the concerned angle is always perpendicular, and the third side is base. And we know it very well that sine theta is equal to P upon H, perpendicular of hypotenuse. Cos of theta is base upon hypotenuse. Tan of theta is equal to perpendicular upon base. And their reciprocals. Reciprocal of sine theta is cosecant theta. So we can write 1 upon cosecant theta here. Reciprocal of cos is secant theta. So we can write 1 upon secant theta here. And reciprocal of tan theta is cot theta. So we can write it equal to 1 upon cot theta here. Now we'll talk of these angles in the quadrants. These are the 4 quadrants, and now we'll consider where these trigonometric functions will assume positive values and where negative. But before moving on to that, we will look into the table of values of sine, cos and tan. So some standard angles I am taking here, and these standard angles are 0 degree, then pi by 6, that means 30 degree. It is 0, or you can say 0 degree. Then pi by 4, that means 45 degree. Pi by 3, that means 60 degree. Pi by 2, that means 90 degree. And the values of, first of all we see the values of sine of the angle. So what we have to do? First of all we will have to learn the method how to keep these values in mind. So you write just 0, 1, 2, 3, 4. Divide each of these by 4 and then take their square roots. And what you are going to get are the values of sine. 0 divided by anything is 0 and square root is once again 0. So these are the values of sine now. 1 upon 4 square root is 1 by 2. 2 upon 4, this 2 will be cancelled. You will be left with 1 upon root 2. Here you will get root 3 upon 2. And 4 upon 4 will be cancelled. Square root of 1 will be 1. So value of sine 0 degree is 0. Value of sine 30 degree, or you can say sine pi by 6 is 1 by 2. Sine 45 degree means sine pi by 4 is 1 by root 2. Sine 60 degree, that means sine pi by 3 is equal to root 3 by 2. Sine 90 degree, that means sine pi by 2 is equal to 1. Now we move on to the values of cos. What you have to do, you are just to write these values in the reverse order. So you start with 1, then root 3 by 2, then 1 upon 2, root 2, then 1 upon 2, and in the last you will get 0. That means cos 0 is 1, cos 30 degree, that means cos pi by 6 is root 3 by 2, cos 45 degree, that means cos pi by 4 is 1 by root 2, cos 60 degree, that means cos pi by 3 is 1 by 2, and finally cos 90 degree, or you can say cos pi by 2 is equal to 0. So these are the values of sine and cos. Now we will move on to the values of tan. We know that tan theta is nothing but sine theta divided by cos theta. So what you have to do, you are just to divide these values. So for tan 0 degree, what you have to do, 0 divided by 1. So 0 divided by 1 is 0. Now tan 30 degree, or you can say tan pi by 6. Divide 1 by 2 by root 3 by 2. So this 2 will be cancelled out. and you will left with 1 upon root 3. Tan 45 degree or tan pi by 4. You divide 1 by root 2 by 1 by root 2. Since numerator and denominator are both same, they will be cancelled out to give the value to be equal to 1. Then tan 60 degree, or you can say tan pi by 3. Divide root 3 by 2 by 1 by 2. 2 will be cancelled and you will be left with root 3. And in the last, tan 90 degree, that means tan pi by 2 is 1 upon 0, and 1 upon 0 is not defined. So it is not defined. So these are some of the important values of sine, cos and tan in first quadrant, and these are some important angles: 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Some more angles may also be required, like 18 degree, 36 degree, 54 degree and 72 degree, 15 degree and 75 degree, which we will discuss later on. Also, the value of, if you will talk of values of cosecant, secant and cotangent, it's not difficult. For the values of cosecant, what you have to do, you are just to take the reciprocals of the values of sine. So cosecant 30 degree will be reciprocal of 1 by 2, that means 2. Cosecant 60 degree will be the reciprocal of sine 60 degree, so it will be 2 upon root 3. Value of secant 45 degree will be the reciprocal of value of cos 45 degree, and the reciprocal will be root 2. The value of cot 30 degree, that means reciprocal of tan 30 degree, reciprocal of 1 upon root 3 is root 3. So from here you can also get the values of cosecant, secant and cotangent by taking reciprocals of sine, cos and tangent respectively. So these are the important values in the first quadrant. Now we'll move on to the next values, but that I'll continue in the next video. The second part of the trigonometry I'm going to stop here, and in advance I'm going to thank you for liking my videos, for sharing it with your friends, especially +1 students, and subscribing my channel. Thank you once again.